All right, as the title says, optional, make into the quadratic formula. I might get some flack from some of my colleagues when I say that if you don't understand this, that's okay. However, I do think it's important to know. I'm not saying it's not important. I think it's important to know. I think just some of you may, especially in this remote learning type of environment, may find this confusing with the number of variables and complexity of the equation deriving this quadratic formula. In the next video, we'll actually just say, here's a quadratic formula and let's use it. But what this is there's a way. This is a way to find the zeros and create a formula that will allow us to find the zeros of a quadratic, whether or not the graph even crosses the x-axis. Never mind if it's easily factorable, but whether or not even crosses the x-axis when there would be no factorization in our standard format of factoring. So we're going to just work with y equals ax squared plus bx plus c. We're going to start with no numbers. And starting with no numbers, we will be able, other than the fact that we're looking for the zeros, we will be able to find the zeros and derive a formula that will allow us to find the zeros. This formula does become important when you're crossing the border. If you ever get a chance, ask the other Mr. Carlucci, what did you do? Or what were you asked when you were crossing the border? And he said you were and you told the border guard that you were a math teacher. You were asked for the quadratic formula. If he didn't know that, he may have not been allowed to cross the border. True story. Anyways, we're going to factor this. We're going to find the zeros. And so we're going to start with not factoring, but actually dividing out the a. I want to get rid of the a from the x squared. I just want to have that x squared all by itself. This will allow me later on to get the x out of things when we go down to making ourselves an equation with the completing the square portion, because we're going to use completing the square. So we're going to do this similar to completing the square, except we're going to divide out the a from everything. So if we divide the a out of everything, we're going to be left with x squared here. Dividing b by a and dividing c by a and dividing 0 by a. So we've divided this first term by a, we're just left with x squared. We divide the next term by a, we're left with b over a. Divide the next term by a, we're left with c over a. And divide 0 by a, we're just left with 0. So that there makes some fractions that we can then work with. Given the x squared, this allows us to make our perfect square trinomial and continue on our merry way. So because there's no a value, we don't have to worry about putting some extra parentheses in here yet. We will, just to keep it clean. So we're going to make a perfect square trinomial. And again, perfect square trinomial worries about the first two terms, x squared plus b over ax. We're looking for 1/2 of b over a squared to be added and subtracted. So 1/2 of b over a is b over 2a squared minus b over 2a. So we're adding and subtracting 1/2 of that term. That there has created a perfect square trinomial right here. And then this portion here, we can multiply out. So we're multiplying by our a value, which is 1, because there is no a value listed. So we have x squared plus b over a x plus b over 2a squared minus b over 2a squared plus c over a equals 0. Now, the reason, again, I mentioned this when we were doing the completing the square. I like the fraction method because this here, boom, we don't have to worry about this b over 2a and squaring that out. It's taken care of because we know that if we make that if we factor that perfect square trinomial at the start, we're going to be left with x plus b over 2a squared. Done. That first portion is factored. This next portion, though, we do have to expand it out. Minus b squared over 4a squared plus c over a equals 0. Now it's just starting to get a little heavy on one side, especially the 0 on the other. So I'm going to actually rework this a little bit, and I'm going to move these two terms over to the other side by adding negative b, or adding b over 2, or sorry, b squared over 4a squared, and subtracting c over a. Then I can just drop this down to one term on this side. So x plus b over 2a squared equals, again, as we move that subtraction over, it becomes an addition, b over 4a squared. So b squared over 4a squared. And then minus c over a. So that just makes, I find that makes it a little like less lopsided. Now, we're subtracting fractions. We need a common denominator. Common denominator between these two is 4a squared. So let's fire that together. To make a into 4a squared, we multiply it by 4a. So we multiply the top by 4a as well. And now we can simplify that. So we got x plus b over 2a all squared equals b squared minus 4ac all over 4a squared. Now, next step. X plus b over 2a squared. We want to get this down. We're trying to find x. Well, we got an x. We're down to an x. We just got to make it by itself. So how do we undo everything that's stuck over here? Well, the first thing is to get rid of the squared. So how do you get rid of a square? You take the square root. Take the square root of both sides. So take square root of this side. We're going to be left with x plus b over 2a. Take the square root of the other side. We're going to have the square root of b squared minus 4ac over 4a squared. Now, a square root can be used separately on the top and bottom of a division question. So, x plus b over 2a equals the square root of b squared minus 4ac. And if I take the square root of 4a squared, I'm going to get 2a. Well, looky here. I got a 2a on this side. I got a 2a on the bottom of a fraction on this side. I'm going to move this over and subtract it. That'll leave me with x. X equals b. All right, wrong word. Negative b over 2a. And I'm going to put this first just because this is how the formula actually works out. Now, quandary. Square root is either a plus or a minus. And we've talked about this before. So it's plus or minus the square root of b squared minus 4ac over 2a. So we can just combine the tops now because we already have a common denominator. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This here is called the quadratic formula. Filling in, given standard form, filling in b, a, and c values, you will find from any quadratic in standard form, you will get the zeros. One will end up being with a plus, the square root of b squared minus 4ac, and the other will be with a minus, the square root of b squared minus 4ac. This here formula, again, we're going to be using it you can use it to find the zeros of any quadratic. However, I wanted to show the derivation of it because I think it's important. Again, if you don't understand the derivation, that's okay. You're not going to be tested on it at any time. However, I think it's important to show that and to be able to prove that we're not just making things up out of thin air in mathematics.